All right, now let's work on solving quadratic equations by using tables. So how could you find the solution to a quadratic equation from this table? What would you look for? Well, we know that when we are solving quadratic equations, we are looking for the zeros. We also know that the zeros are the same thing as x-intercepts of our quadratic function. And what's so special about the ordered pairs of the coordinates of x-intercepts? We know that it's always on the x-axis, so the y should always be equal to 0. So basically, in a table, you just need to look for where y is 0. I see one right here, and another one right there. So when we look for zeros, it's super easy on a table. Look for where y is 0. But what if I didn't give you a table? Like number 5 here. You see the equation x squared minus 7x plus 6 equals 0. And now we have to fill out this table to figure out where the zeros are. Before, when we were graphing, you could choose, any x values to plug into the function and find the y values to make a table, right? But how do we know which x values to plug in here so that we can definitely see the x-intercepts or the zeros? Let's think back to what we did when we were graphing. What did we do first when we were graphing a quadratic function to find the zeros? Well, we noticed it was in standard form, and we found the axis of symmetry first. So let's try that. X equals negative b over 2a. In our case, that would be positive 7 over 2 times 1. So our axis of symmetry is at x equals 3.5. Cool. And since I know this, I can also find the vertex by plugging in the x value of the axis of symmetry. For this part, I'm going to use a calculator. So I have 3.5 squared minus 7 times 3.5 plus 6. And all of that comes out to negative 6.25. So this is our vertex. And if you remember, when we were graphing, we really tried hard to visualize the parabola from what we know. So we know that the vertex is at 3.5 comma negative 6.25, which is probably like something right there. 3.5, negative 6.25. We also know that this function is a positive function because the a value is positive 1. So we know the parabola will be going up. I also know that the y-intercept is at 6, positive 6, so probably somewhere up here. So that means the parabola, will look kind of like this. That's my bad sketch of it, you guys. Let me just make a better sketch. There we go. All right, so now we have some more information. Look at this. We know that there has to be a 0 somewhere between x equals 0 and x equals 3.5, between the vertex and the y-intercept. We also know then that there will be another 0 on the other side, the same distance away from the axis of symmetry. So I'm going to start filling out this table from 0. And we already know what this value is because that's our y-intercept. So when x is 0, y equals 6. So now let's just plug in some x values and figure out the rest of the table. This time I'm going to try plugging in x equals 1. So f of 1, let's see, that's 1 squared minus 7 plus 6. 1 minus 7 plus 6. Well, 1 minus 7 is negative 6. Plus 6 is, hey, 0. Right away, we were really lucky. There's a 0 at x equals 1 right here. That value is how many units away from the vertex? Well, since Our axis of symmetry is at 3.5, and this is at x equals 1. That's 2.5 units away. I'm doing that because I know that 2.5 units away on the other side will give me the other 0. So 3.5 plus 2.5. Hey, that's at 6. So at x equals 6, we'll probably have another 0. Knowing that, I'm just going to fill out the rest of the table with x values that I can fit in here. So now I'm going to plug in x equals 2. That's 4 minus 14 plus 6. 4 minus 14 is negative 10. Negative 10 plus 6 is negative 4. And then if I plug in f equals f of 3, that's 3 squared, so 9. 9 minus 21. What is 9 minus 21? It is negative 12. Negative 12 plus 6 is negative 6. So when x is 3, y is negative 6. I know when I plug in 3.5, our y will be negative 6.25, because that's our vertex. And from then on, since our parabola is symmetrical, I can just kind of copy these y values. When x is 4, y is probably at negative 6, because it should go back up. Then x equals 5 will be at negative 4, and x equals 6 should be at 0. X equals 7 will be at 6. So our two zeros of this function is at x equals 1 and x equals 6. Now let's check this with an actual graph of this function. I use Desmos to look at the parabola of this function, and look at this. X equals 1, x equals 6. We were exactly correct. Remember, when you find the vertex and determine the direction of your graph, you can figure out how many zeros a quadratic function has. And that information will really help you when you make graphs or tables to be able to solve your quadratic equations.